So in this intro video here, we're going to look at what is data science. But before we dive into what is data science, we first need to ask the question, what is data? So I'm going to give this very simple definition that data is information. And in this class, what we're going to be looking at, it's mostly going to be in numerical form, but it doesn't always have to be, but mostly data is information in numerical form. So now that we know what data is, let's look closer at what is data science. So the definition I'm going to give here is that data science is the collection and study of data for analysis and to gain meaningful insights. And in the modern world, with the advent of the computer, it's become very important because we can now easily store data on just about anything, any topic. So let's look at what can we gather and store data on. So we can gather it for almost any field you can think of, whether it's sports, weather, medical field, business, education, demographics, which is the study of people, finance and money, science, economics, and even crime-related data. So again, that's only 8 fields I brought up, but pretty much every field of study you can think of relies on gathering and studying data. I could list, 100 more, but for sake of time, I only listed a few. But really, again, know that every field of study relies on gathering and studying data. So now you're asking yourself, why? So let's answer that. Let's look at the goal of data science. And you should always ask yourself why in anything, but when studying data, there's really 2 main goals here. The first is just to gain insights and knowledge. So you look at the data and just what is it showing you? The second is to actually use that data and insights to improve and continue to become more and more efficient. So if there's to be one word to narrow it down, I would say the goal of data science is about efficiency and becoming more efficient. And you use the data to help you do that. So let's look at each one of these fields I brought up and we'll look at an example. So first let's look at sports. So in the case of basketball, a basketball team can examine where their team is shooting the best percentage from, and then they can try to shoot more shots in those areas and improve their efficiency. In the field of weather, meteorologists study past weather data and weather patterns so they can make more accurate predictions in the future. In the medical field, doctors study vast amounts of health data to make better predictions and more accurate diagnosis for patients in the future. Businesses study financial reports to see where they can improve, where they are doing poorly, and so they can maximize their profits. Schools all over the country study student data to see what strategies work, what doesn't work, and in the end, they use this to improve the educational experiences for all future students. Demographics is the study of people and the movements of people. So researchers and economists study demographic data of states, cities, and countries to see where people are moving to, and then they can ask the questions, why are people moving some places versus other, and they let the data guide them on this. Banks and financial regulators study spending habits of customers to find better investment strategies and make better investments for themselves in the future. Let's move to science. So almost every field of science essentially are just data scientists, whether it's biologists, animal scientists, environmental scientists, chemists, physicists, they all use data and examine data based on their hypothesis to see if their hypothesis were correct or incorrect, and then they can move forward going from there. But all fields of science essentially are just data scientists at their core. Economists at their core are pretty much just data scientists as well. What they do is they study economic data of cities, states, and countries to figure out which economic system seems to be most beneficial for its citizens, and then they can spread that knowledge elsewhere. Economists and police departments also study crime data across cities, states, and countries to figure out what policing strategies seem to decrease crime and increase crime and move for or away from certain policies. So again, those were some very broad examples of each topic because we do have limited time. And so now I'm going to jump into the data science process. And so all of those respective fields will follow essentially the same process in gathering and looking at their data. And so really there's 4 primary steps. So let's go over each one of those right here real quickly. So the first is the collection and gathering of the data. The second step is the organization and cleaning of the data. The third is the study and analysis of the data. And then the fourth step and last step is the action or next steps taken based off the data. So in that first step, what you're really doing is you're just getting all the data you need. And the second step is when you gather it, it's not going to be all nice and clean and organized. So what you do in the second step is you get the data organized and cleaned so your analysis is much easier. Then when the data is all nice and sorted out, now you can move on to step 3, and that's where you're going to study and analyze the data. You're going to examine it and just look at what is the data showing you. And then after your analysis, you move on to the final step, which is you take your actions or next step. So what you're going to do is you're going to use the analysis to make changes that will be beneficial to your organization or company. So that is a broad overview of the data science process, and almost every single organization or company uses this exact same template in their data analysis process of collection, organization, study, and then next steps. So one last thing before you go, and that's going to be this piece of advice is don't be biased. It's a huge thing in the field of data science is don't be biased. I'm going to say it again. What you want to be is open-minded. I really can't stress how important this is in the field of data science to be open-minded and unbiased, because you want to let the data guide you and you don't want to go into it with, well, I want this to be the outcome, and so then you kind of cherry pick the data to be the outcome that you want it to be versus what the true data is. So again, I'm just going to hammer that in, be open-minded, because what you don't want to happen is, like I said, don't guide the data. What you want to do is let the data guide you. And so you just are looking at the data unbiased, and what does the data say? Doesn't matter if it goes against what you originally thought. If it's true, it's true. If what you originally thought is wrong, that's okay. It's based off the data. So I'm going to leave you with this clip from Bertrand Russell. He was a mathematician in the mid-1900s about this unbiased approach and just letting the data guide you.
Ask yourself only, what are the facts and what is the truth that the facts bear out? Never let yourself be diverted either by what you would wish to believe or by what you think could have beneficent social effects if it were believed. But look only and solely at what are the